Okay, so I think mouse disaster is averted. So I could just hear I heard the cat come in and thought, oh fine, maybe I'll come and say hello. And then I suddenly heard the squeaking of a mouse. So I've now shut the kitchen door, so hopefully even if a mouse is brought in, it'll only be brought into the kitchen, rather than what you did just now, which is bring it into the living room. And it went under the sofa. Luckily, the mouse was stupid and then came back out from under the sofa, so the cat grabbed it, rather than going deeper and deeper under the sofa and my cat not being able to get it. Or me not being able to get it and it coming out later. So, yeah, I think I've got the cat back outside now with the mouse. And, I mean, that poor mouse. But, hopefully it won't be back in my house. Anyway, question number 1. Part B. Find the range on the horizontal plane. So we're resolving horizontally. The displacement is R. The range, my initial horizontal velocity is U cos alpha. My acceleration is 0. And the only other information I can use is time. Well, I know from the previous example what an expression is for time, which is 2u sine alpha over g. So I can now hear my cat meowing because I've got the kitchen door shut. And he obviously wants to come in and say hello now. Anyway, right, so SU and T, so S equals UT plus half AT squared. Because we're talking horizontally, we don't need the plus half AT squared. So we've just got velocity times by time. So we've got U cos alpha multiplied by 2U sine alpha over g. So we're going to tidy this up. So 2u squared sine alpha cos alpha over g. Now I expect you can leave it like that, but if we can reduce the number of trig equations we've got in there, then we ideally will. So I need to know my double angle formulae. 2 sine alpha cos alpha is sine of 2 alpha. So the range R therefore is u squared sine 2 alpha over g. Okay. So I will do example number 2, but my cat is meowing so much that I'm going to go and let him out. If suddenly the video stops, it is because I've had to stop the video and cut the end off and do another video because he's got something. If I come back in a few seconds and I'll put in the description how long to fast forward for, then it's simply the cat saying hello to me. So good, I have a cat, I have no mouse. The cat will probably join in this video. But, oh, what a day. We're all getting tired of lockdown, I think. Anyway, example number 2. This one is quite a bit longer, and as you can see probably looking at the equation, that it's going to require a bit more working. Yes, hello. So a particle is projected from a point with a speed u at an angle of elevation alpha. Oh, cat's on my lap, so I'm trying not to. There we go. So, hello, there's Toby. Can you not? At least this video is going to be slightly more entertaining. There we go. You can stay on my lap, not on my desk. Right. A particle is projected from a point with a speed u at an angle of elevation alpha and moves freely under gravity. When the particle has moved a horizontal distance x, don't really know why I put my x there, my x should be there, its height above the point of projection is y. So however far its horizontal distance is x, and its vertical distance at that same point is y. It's been really noisy today. So as always, I need my horizontal component and I need my vertical component. I haven't done that very well. By the way, my cat is not in pain or anything. He's just being really vocal. He's just being annoying, is actually what he's being. But there you go. Right. So, show that y equals x tan alpha minus gx squared over 2u squared 1 plus tan squared alpha. So, because we need an expression for x and an expression for y, we are going to have to resolve both horizontally and vertically. And we're going to need to combine the two equations. Now, we obviously need to substitute x into y from the expression that we've got. But we haven't really got many different, or we've got a few different variables, but not enough really in the final equation. We've got alpha, we've got u, and we've got x, but we haven't got anything else. So we need to think of something that is going to be consistent between an equation for y and an equation for x. And that is going to be time. Because the time that the particle is here will be the same for both x and y. So I'm going to resolve horizontally. So my displacement is x. My initial horizontal velocity, u sine alpha. Time is time, and acceleration is 0. So horizontal displacement is just displacement is equal to velocity multiplied by time. So ut sine alpha, reading my work wrong, cos alpha. Sorry about that. I should do these in colours really so that I can see what I'm doing, but there we go. Okay, so x is ut cos alpha. So I'm now going to resolve vertically. So the vertical displacement now is y. The initial vertical velocity is u sine alpha. Acceleration is negative g because I've defined upwards as positive. And again, time is just time. So y is equal to, so ut, so ut sine alpha minus g over 2, because it's half a t squared. Okay, so I want to get an expression for x into y. Now there is no t in my show that question, so I need to eliminate t. So I need to substitute an expression that contains x, but we haven't got an expression that contains t. So I'm going to rearrange this to make t equals and eliminate t. So t is equal to x over u cos alpha, because obviously divided by u cos alpha. So now I'm going to substitute that in to this expression. So y is equal to u x over u cos alpha sine alpha subtract g over 2 x over u cos alpha squared. So we can tidy this up a bit. Now this bit is quite easy to tidy up because you've got a multiplied by u and a divide by u, so that cancels. Sine alpha over cos alpha gives me tan alpha. So I have x tan alpha, which is what I, absolutely what I want. And I just realised how wonky the camera is. I apologise about that. So y equals x tan alpha. Tidying this up will be slightly more challenging, so I'm just going to square it first. So I've got g over 2, lots of x squared over u squared cos squared alpha. Now, at this point, if I didn't have something to go to, I might find it quite challenging, but I have what it should look like at the end in my question. So what I'm going to do before attempting to try and tidy it up is I'm going to take out x squared and u squared because that's not part of the 1 plus tan squared alpha. So y equals x tan alpha minus g x squared over 2u squared, lots of 1 over cos squared alpha. Now, I know 1 over cos squared alpha must be equal to sec squared alpha, because 1 over cos alpha all squared would be sec squared alpha, and they're obviously the same thing. So I'm going to replace that in my next line. Y equals x tan alpha minus gx squared over 2u squared multiplied by sec squared alpha. Now what I also know, and I'm going to use another colour now, I need to get to 1 plus tan squared alpha. So I'm evidently going to need another identity. Tan squared alpha is equal to sec squared alpha minus 1. So therefore sec squared alpha is equal to 1 plus tan squared alpha. So for my final step, I can substitute that identity in. X tan alpha minus gx squared over 2u squared 1 plus tan squared alpha as required. So that's quite a lot of working for that question. It's because there's a lot of substitution. It is a show that question, so whilst you wouldn't actually have to do these bits on the side in the different colours, you would be expected to show all the actual steps of working, okay? You can't just skip steps with a question like this. That is definitely the hardest part of that question. Once you've done that, the second part really isn't too bad. So part B of that example, a particle is projected from point O on a horizontal plane with a speed of 28 meters per second at an angle of elevation alpha. The particle passes through a point B, which is at a horizontal distance of 32 meters and a height of 8 meters above the plane. Find the two possible values of alpha, giving your answer to the nearest degree. So because it's a follow-on question, it evidently wants you to use your answer from the previous question. So that is y equals x tan alpha minus gx squared over 2u squared 1 plus tan squared alpha. Oh dear. Now it's obviously set up so that even if you couldn't do the show that part, you can still answer this question. So y is equal to 8, x is equal to 32, and u is equal to 28. So obviously we know g is equal to 9.8, which we would assume in this question. So therefore 8 is equal to 32 tan alpha minus 9.8 times 32 squared over 2 times 28 squared, brackets 1 plus tan squared alpha. So 8 equals 32 tan alpha. Obviously you want to tidy this bit up. That's minus 6.4 1 plus tan squared alpha. Now actually if we continue to expand this, we can get a nice quadratic. So 0 is equal to minus 8 plus 32 tan alpha, subtract 6.4, subtract 6.4 tan squared alpha. So I've expanded this bracket and made it equal to 0. Tidying up all the constants, I get 0 is equal to negative 14.4 plus 32 tan alpha minus 6.4 tan squared alpha. So if I let tan alpha be y, so 0 is minus 14.4 plus 32y minus 6.4y squared. It's a bit easier to see how I could solve this and put this into our calculator. So I'm just going to use my polynomial solver, and when I solve, I get y is equal to 4.5 and y is equal to 0.5. So obviously tan alpha is 4.5 and tan alpha is 0.5. Therefore, to the nearest degree, alpha is either 77 degrees or alpha is 27 degrees. So it says find the two possible values of alpha, but for some of you that might be quite difficult in terms of conceptually what is it that we're finding. Well, what it implies to us is that there are potentially two possible paths of projection. You either got a really steep path, so that initial path had quite a steep angle, let's say 77, or we have a much more shallow angle of projection like this, which may have been 27 degrees. So this would be the point B, 32 metres and 8 metres. It's got potentially two different paths when it does that. So on the final slide, it summarises all of those formulae. It actually puts a couple of them in a slightly different way, which is evidently not helpful. It also gives you the time to reach the greatest height, and it gives you what's called the equation of trajectory, which is the y equals formulae. So you don't actually need to learn these formulae. You do need to know how to derive them. So when you're solving problems, please do not solve them using these formulae unless it's obviously a subsection of the question where it's easier. It is just within those derived questions that you would do that. So in exercise 6D, I don't really want you to do loads of questions. What I'd like you to do is to find the one that would derive the time to reach the greatest height. Make sure you do one of those. And maybe do a question where it says derive it, just to practice it, and then do a subsection. But yeah, I think as long as you have sort of knowledge of your CVAT equations, your knowledge of understanding how to substitute values in, using time as a parameter if you've got two different equations to rearrange, then these problems are not as challenging. But it's more important that you're able to solve projectile problems generally. So hopefully, despite the distractions. That was somewhat informative. And I apologise for my cat meowing the whole way through and the mouse incident. So, yes, I think nearly 5 weeks in, even the cat's losing it with me being here. But yeah, there you go.